Hello friends, welcome to engineering tutorial. Now in today's video we are going to study about another very important concept related to basic circuit analysis, which is the star to delta transformation or star to delta conversion. Now this concept is very useful while analysis of resistive circuits because it is used to calculate or to make the calculation of equivalent resistance of a circuit easy. Sometimes you may come across a circuit where you can neither apply the series combination of resistors formula or the parallel combination of resistors formula. The resistors will be arranged in such a form that will be very difficult to calculate the equivalent resistance. At that time you need to have some way, you need to have a strategy how to simplify the circuit, how to make some manipulations or alterations in the circuit without changing the circuit behavior, the circuit characteristics, that is the voltage and current relationship, so that you can simplify the circuit structure and calculate the equivalent resistance of the uh, particular circuit. In that case, the star to delta transformation or conversion techniques come in handy. Okay, so first let us understand what is a star connection and what is a delta connection. Now you see here there are three resistors R1, R2 and R3 connected in a star shaped structure. Okay, this is point 1, this is point 2 and this is point 3. Resistor R1 has one of its end connected to point 1, the resistor R2 has one of its end connected to point 2 and resistor R3 has one of its end connected to R3, and the other ends of the resistor is connected at one common point. So this is the star shaped structure. Okay, it is also called as T structure, T-shaped structure, because if you flatten the upper portion it will be a T-shaped structure. Okay, it is also called as T-shaped structure, but here we will call it as star-shaped structure. Okay, this is whenever you come across any resistor connection like this, it means that they are connected in star-shaped manner. Now here, in this diagram you can see that the same three resistors, okay, they are connected across the same 3 points 1, 2 and 3, but here their values are different. Okay, in between the same 2 points 1 and 2 there is another resistor value R12, in between the points 2 and 3 there is R23, and in between points 3 and 1 we have R31. So basically what we have done is we have converted this star shaped structure into delta form, and the resistor values they have changed to R12, R23 and R31. So the next thing which we have to study is how to convert this star shaped into this form. It is called as the delta form. Okay, the delta shaped structure, this shape. So how we can convert the star shaped structure to delta shape, or the delta shaped structure to star shaped as per our requirement for simplifying the circuit diagram. Okay, another thing, this delta shaped structure is also called as pie shaped structure. Okay, it is also called as pie shaped structure, but here we'll call it as delta shaped structure in the shape of a triangle. Okay, the shape of a triangle is also called as delta, so we call it this form as delta shape, and we have got this from this star shape. We have just made some manipulations in the resistance values and we got this shape. So how now we'll understand, now we'll study how to make these alterations so as to convert star shape into delta shape or delta shape into star shape. So first we will study the star to delta conversion. That is, if we have a star shaped resistive structure how we can convert it into its equivalent delta form. Okay, so suppose you have a structure like this with the values of resistance R1, R2 and R3 being given, they are known, and we have to convert it into delta form. So for that we need to find out the values of R12, R23 and R31, which are unknown to us. So the conversion formula is something like this. The R12, the resistance value R12, which is connected in between points 1 and 2, is equal to delta by R3, where delta is this R1 R2 plus R2 R3 plus R3 R1. Similarly, R23, the resistance value which is connected in between points 2 and 3, okay, 2 and 3 is delta by R1, and the resistance value R31, which is connected in between points 3 and 1, okay, 3 and 1, this resistance is delta by R2. Now, one easy trick to remember this formula is that this thing is fixed in all the three values R12, R23 and R31 in the numerator. This value is fixed, R1, R2 plus R2, R3 plus R3, R1. So in order to evaluate or calculate a particular resistance value, pay attention to the subscript here. Here we have to calculate R12. So in the denominator we have R3. So here the subscript is 3. Here the missing number is 3, which is in the denominator R3. Similarly here in the subscript R23, the missing number is 1. So that is the resistance value which we have to place in the denominator, delta by R1. Delta is fixed and R1 is the missing number here. In R23 the missing number is 1. So that is that resistance value you have to put in the denominator. Similarly here R31, here the missing number is 2. In R31 the missing number is 2. So that resistance value R2 we have to put in the denominator, and the numerator is fixed in all the three interconversions, the three values. The delta is fixed, which is R1 R2 plus R2 R3 plus R3 R1. So all you have to do is point out the missing number, which is here R12, the missing number is 3, so R3 you have to put in the denominator. In R23 the missing number is 1, so you have to put R1 in the denominator, and in R31 the missing number is 2, so you have to put R2 in the denominator. Again I repeat that the values R1, R2 and R3 are known to us. Okay, they have certain values of resistance. All we have to do is determine these values R12, R23, R31. Okay, using this formula and the trick which I just said. All you have to do is identify the missing subscript, the missing number in the subscript, and we have to divide that resistance value in the denominator, and the numerator is fixed, which is this R1 R2 plus R2 R3 plus R3 R1. Okay, so next we will study how to convert this delta form into star form. That is, we have this delta form given to us with R12, R23 and R31 known, and we have to find the values of R1, R2 and R3. So let's see how we can do that. So next we are going to see the delta to star shaped conversion. It means we have a structure given in the form of delta shape with R12, R23 and R31 known. They are known values. R12, R23 and R31 will be known, and we have to convert it into the equivalent star shaped structure. So in order to convert this delta structure to star form, we have to calculate the values of R1, R2 and R3, which are unknown to us. So for that we will use these formulas. Now R1, the value of R1 is equal to R12 into R31 by star. this star is equal to R12 plus R23 plus R31. Now similarly, in the star to delta conversion we used a trick. Here also there is a trick involved. Suppose you have to calculate the value of R1 here. In the numerator there will be all the resistance value which has 1 associated in the subscript. See here, we have to calculate R1. So in the numerator there is R12 and R31. Both the resistances R12 and R31 have 1 involved in it. Okay, both the resistances R12 and R31 have 1 involved in it. It means one of their ends is connected to point 1. And the star is constant in all the denominators in the 3 formula, which is R12 plus R23 plus R31. So all you need to do is remember the value of star, which is R12 plus R23 plus R31, which is the fixed denominator. Next you have to remember this trick, that whichever resistance you have to calculate, pay attention to the subscript which is there, R1. So you have to multiply all those resistance values which have 1 in common with. It means one of the ends of the resistance is connected to this point 1. Similarly, R2, the subscript, in the subscript there is 2 present. So you have to multiply all the resistances which have 2 involved in them, that is R12 and R23. It means R12, R23, in both the resistances one of the ends is connected to point 2 and the denominator is star, which is fixed, R12 plus R23 plus R31. Similarly, R3, in the subscript there is 3, so you have to multiply all the resistances which have 3 involved in it. So R23 and R31. R23 and R31, both the resistors are connected to, one of their ends is connected to point 3 and the denominator is fixed, which is R12 plus R23 plus R31. So it's simple, the denominator is fixed. In this case the denominator is fixed. In star to delta the numerator was fixed. In delta to star the denominator is fixed, okay, which is this value. All you have to do is pay attention to the subscript and multiply all those resistances which have that subscript number involved in it. Here there is R1, so you have to multiply all the resistances which have one of their ends connected to 1, which means R12 and R31. Similarly for R2 it will be R12 and R23. And in R3 there is R23 and R31. Okay, so there will be only changes made in the numerator and the denominator is fixed, which is this value. So in this way you can convert any star shaped structure into delta or delta shaped structure into star. So in order to understand the usefulness, the advantages of this star to delta or delta to star conversion, we'll solve some numerical problems involving complex arrangement of resistances, and we'll use these techniques to simplify those circuit diagrams. So this is all about the conversion of star shaped structure to delta and delta shaped structure to star. So previously I was saying that the star shaped is also called as the T shape and the delta shape is also called as the pi shaped. So what I meant was that suppose you have this star shaped structure, okay, it is drawn in this way. You can also draw the same structure in this way, okay, it looks like a T shape. So this structure and this structure, they are the same, there is nothing to be confused. The delta shape is same as the T shape. What we have done, we have just lifted this portion, this common point upwards, we have flattened out, and the delta shape and the T shape, they are the same. So if you come across a shape like this, you can apply the same star to delta conversion formula to get the equivalent delta shape. Okay, so the star shaped and the T shaped, they are the same. They have the same resistance values in between the same 3 points, 1, 2 and 3. Here also 1, 2, 3, here also 1, 2, 3. Similarly, the delta shape with the resistance values which are drawn in this way, it can also be drawn in this way. Okay, so here we have 3 points 1, 2 and 3. Here also there are 3 points 1, 2 and 3. These 2 points are the same, they are just shorted together. Okay, they are shorted together. So these 2 points are the one common point, they are the same. These 2 points are the same. So whenever you come across this shape, which is called as the pi shape of a resistive connection, you can also apply the same delta to star conversion to get this structure or this structure. Okay, so this pi shape is same as the delta shape. There is nothing to be confused about the pi shape and delta shape, they are both the same. The star shape is same as the T shape, the delta shape is same as the pi shape. Okay, so here we have discussed about the star to delta and delta to star conversion using the various formula, and I've also given you some tricks, some hacks and tricks to quickly determine or to quickly calculate the various resistance values. And also we have discussed about the similarity between, means they're the same, the star shape and the T shape, and the delta shape and the pi shape. Okay, the delta shape is same as the T shape, and the star shape is same as the T shape, and the delta shape is same as the pi shape. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.